Aisha, I'm going to try to get as many of your questions answered right now because I have to go to mom's. So the first question you had that you were asking about was this one about a probability of a random variable is, and it had a bunch of answers. Um, when I say we, Ajay and I think this is a poorly worded question because we feel from the answer the intent that your teacher had was to understand the formal definition that a random variable is actually a function that takes on values. And if it's not defined and you don't have a specific question, you can't answer that question with the information given. So they had the selection of none of the above. But actually, your answer is technically correct because it could be 0.01, 0.5. It could be any one of these things. So, but he had none of these because you can't put your finger on a particular choice. So that's why it was none of these on that one particular one. The second question that, and I didn't get to the third one, which is very similar that you were asking about, but you had 23 defective items and you wanted to, and there's 1,000 and it applies the sample-driven probability that you have one defective item is 0.023, where the random variable is the number of defective items. We think that the real question that's being asked here is that, which is not stated in the question, that if 50 are selected from the 1,000, what's the probability that you're going to get 3 or less being defective? And you would use what in mathematics called the binomial, but it's the choose function to do this because you're choosing things out of this 1,000 sample. That's really, really important that that's what you're doing. So let's say I had 1,000 total, and I know that 23 are bad inside those 1,000. Well, that means 977 of those are good. If I wanted to calculate the probability that exactly 3 were bad, I would do 977 out of these 50. If I have that, how many of them are good? Well, the 977 are good, and I choose 50 out of these. And then I multiply by the probability that I chose exactly 3 of the bad ones in that 50. So that's how I get this numerator up here. Now, the denominator is the total possibilities of choosing 50 out of those 1,000 samples. So that's going to be my sample space in the denominator. So like I would, how many ways could I choose 50 out of that 1,000? And I did my calculations on Mathematica, so I'm going to open this up. So you see like over here, to do this, this actually I don't need, but to do this binomial is combinations. So if I wanted to do 977 choose 50, this is what I do. So I get 0.303228 if I do this calculation right here. Then if I want exactly 2 are bad, well, that means that out of the 50, I would change these numbers. So it's 23 choose 1 and 977 choose 49. And the denominator would stay the same because my sample space is still, the number of samples I have is 50, 1,000 choose 50. And so I go in here and I can see that that's what I would get if I do this one. So I keep repeating this process. If I choose exactly 1 were bad, I would get everything knocks down, and then I get, this is not 49, this should be 50, not 40, and 23 choose, let's see if I get 49, 48, 40, this should be 47, right? And so out of the 977, 47 were good, and exactly none of them were bad. And so I would have everything change accordingly. So this number is wrong here. And then when I add up all these different slides, what I'm going to get is 0.975691 with some rounding error. That means that you are going to get the answer 0.9758. That's slight rounding error. So that's why it's this particular answer. You're just adding those up. How did you get this answer? That answer comes from the binomial distribution. And And we're not sure why he said this thing. You may not use one distribution as an approximation of another. We're not sure why, but this is a straightforward combinatorial, like adding things up. We think this problem is a little bit hard and confusing a little bit to understand. And also, if you look at the wording, if there are 23 defective items within a population of 1,000 items, what's the probability of observing 3 or fewer defects in a sample of 50 items? It's not clear here that you're drawing this 50 from the 1,000, but you're drawing the 50 from the 1,000, which is why you're having these combinations. So you have to think about how many combinations of total 50 would you have. That's your denominator. And then in the numerator, you're calculating the probabilities of doing 3 defective items, 2 defective items, 1 defective item, and no defective items. So that's 3 or less. That accounts for the 3 or less. And so just so you can see my calculations, here's 1, 2, 3. So this would be that I chose exactly 3, exactly 2, exactly 1 defective item, and exactly no defective items. And then I add it all up and I get this guy down here.